I'm Bill Witherspoon, and I am a geologist. I like to do a lot of programs for the public. I did my doctorate at the University of Tennessee, so I'm very familiar with this area called the Valley and Ridge, or Ridge and Valley, that Cartersville is part of. And I'm one of the authors of a book called Roadside Geology of Georgia, which is a book for the general public about the geology of our state. It came out just a year before I retired from Fernbank Science Center, which is part of the school system in DeKalb County, where I taught for 17 years. And I like to come around and do programs for different groups like the Bartow History Museum. So I think if you talk to a lot of geologists, you will find that they had an interest in rocks as a kid, and I'm no exception to that. And also, we tend to be people who are very interested in maps. And one of the things that got me excited, I was considering various careers, and when I was in college, I hadn't yet decided on this one as an undergraduate. But I went to a museum in London that had the theory of plate tectonics that said that the continents were moving around was just new thinking at that time. This was in the 1970s. And suddenly all these map things made sense. You know, why is there a ring of fire around the Pacific Ocean? Why do the continents on either side of the Atlantic Ocean, like South America and Africa, look like pieces of a jigsaw puzzle that put together? And why are there mountain ranges that go the whole length of continents? And all the answers were suddenly there that hadn't been there before because of plate tectonics. And that's when I decided that, hey, or not too long after that, I realized that, hey, I wanted to investigate this as a possible career. Well, I like discovering interesting things every day, but one of the things that interests me most right now is trying to tie geology into other aspects of life, like history. And so I love to have a talk at a history museum. And the talk that I gave today had to do with, part of it had to do with the way the Civil War came through this area and how much geology influenced what was happening on the ground with the forces. And one thing I didn't get to tell, for example, I gave this talk about geology in the Civil War up at Kennesaw Battlefield, and somebody came and asked me, well, what was this red mud that all the troops were getting bogged down in around Kennesaw Mountain? And I said, aha, that is this mud that comes from a rock called amphibolite that weathers easily and that surrounds Kennesaw Mountain. And so you put stories together like this when people ask you questions, and you know, I've never been I haven't done a whole lot of pure research in my life. I'm much more a geoscience educator. But it always gets me excited when somebody asks a question like that and there's an answer. Geology really connects with all different sorts of things.
Good afternoon. How's everyone this afternoon? Good, very good. Well, for those of you that don't know who I am, my name is Trey Gaines. I'm the director of the Bartow History Museum, and we're glad to have you join us for this Lunch and Learn. Before we get started, let me give you a couple of upcoming announcements for what's coming up in the museum in the next few weeks. Next Thursday night on August 28th, our evening lecture for August will take place. That will be Robert Jones. Robert is a historian and author who's written untold number of books on local and regional history. And specifically, next week, he's going to be here to talk about Cooper's Furnace and the history of Cooper's Furnace and the Etowah Ironworks down here at, underneath Lake Allatoona. On August 30th, our current temporary exhibit on the 175th anniversary of Cartersville, which is on the other side of this wall, will close. So those of you that have not seen that yet, I encourage you to do that while you're here before we close that at the end of the month. Which means there's another exhibit coming. So on September 25th, we're going to open a new exhibit, and the title of that exhibit is Essential Ingredients, The Joy of the Cookbook. And we're going to bring out our collection of historic cookbooks that we have here at the museum and display those along with a nice collection of kitchen implements and utensils. And we have a special speaker that night, Ann Stiles Quattrano, who's a chef and a well-known chef in Atlanta. She's got several restaurants down there, Bacchanelli, Styles Fish Camp, and Star Provisions. She's a Michelin-rated chef who has deep roots here in Bartow County. She and her husband live off Hugh Harley Road and have Summerland Farm, and she's going to be here to talk about her cookbook and her cooking legacy throughout her career. And there's going to be food and door prizes and all kinds of good stuff that evening, in addition to the exhibit opening. And those tickets for that will be coming out in the next week or so, so be looking for that. Also in September, we've got a workshop on the paranormal. And Jordan's going to tell us a little bit about that workshop coming up on September 6th.
All right. How's everybody doing today? Excellent. So we have a very interesting workshop coming up, like Trey said, on September 6th. It's going to be called, it's the Bartow Case Files Paranormal Workshop 101 to celebrate the beginning of the Halloween/spooky season. If any of you have been fans of the ghost hunting shows on television, we're going to have a paranormal investigator. Her name is Stephanie Forte. She's been on the field for about 20 years, and she will come in and teach everybody how to properly conduct one of those investigations and also kind of debunk what you see on the television shows and how it really goes in real life. So you'll get a presentation portion, and then on the back half of that workshop, we will actually do an in-house paranormal investigation here in the museum. And we will also be able to split and do another investigation over at the train depot that same night. So if that's something you're interested in, just a heads up, tickets are very limited. I think there's only 5 of them left for a total of 20 spots. So it's going to be a very fun and interesting night for sure.
And if you're interested in that, you can get those tickets on our website. I will encourage you to take a nap that day because it's at 8 o'clock that night. Also, before I introduce our speaker, we got a great shipment or received a gift from Publix this morning. Fresh donuts and cookies. I've got them on the back table. If you're interested in a little dessert before you leave or while you're here, please take one of those with you. All right, well, without further ado, let me introduce our guest speaker today. Dr. Bill Witherspoon is a geologist and co-author of Roadside Geology of Georgia. He taught undergraduate geology to students at the University of Tennessee, Knoxville, and Chattanooga campuses. He worked for a petroleum company as a software developer and as a K-12 geology teacher for 17 years in the DeKalb County Schools Fernbake Science Center. In 2013, he and Dr. Tallulah Gorge wrote the Roadside Geology of Georgia, which he's got up here. He retired in 2014 as it has presented over 100 walks and talks on Georgia geology. Please join me in welcoming Bill Witherspoon.
Has anybody not, this is my guest book, has anybody not put your name in my guest book yet? Great, so, okay. Well, I'll get started then. This is a program actually when I retired from Fernbank Science Center in 2014. I presented this, and I've been updating it a little bit recently, but this is a program about 3 history interwoven with geology stories. And one of them is about the gold rush. The second one is about the Civil War. And the third one is a little briefer, but it's about when somebody did a tightrope walk across Tallulah Gorge. So I'll try to get to all those 3 and lots of geology, a little bit of history. I'm not a historian. Some of you guys may know more of this history than I do. I'll appreciate if anybody corrects anything that I make a mistake on. But it's fascinating stuff, and I like to kind of interweave these things together. Roadside geology, you think of a book that's about, you're standing by a very busy highway. And it really started out kind of that way as the series started out in a couple of professors in Montana. And they, in Montana, you could describe the geology you see from the major roads and it would fill a whole book. But in Georgia, that would be just a little pamphlet because there's not a lot of geology to see in the roads. This is what's out there now. Since I made this map, there are 4 more that have come out. So this is the Georgia. It was the 2013 came out. But so because we have to go beyond the roadsides, there are all these amazing places in Georgia that have stories behind them. Tybee Island, Cloudland Canyon, Tallulah Gorge, we'll talk about today. And all of them have geological stories associated with them. So that's what we try to tell in the book is, and when I go to other states and I pick up the Roadside Geology book, I often discover places that are off the beaten path that are really beautiful that I might not have found out about otherwise. So kind of a neat series. So the first story I want to tell then is the Golddiggers story. And so Georgia had a 29er gold rush. And gold was not the first discovery in the United States. Gold was discovered 1799 near Charlotte. Part of the reason they built a mint in Charlotte, and that's part of the reason that Charlotte became a financial center and grew with those big banks and so on in Charlotte. So we had that 1799 discovery in Charlotte. The folks down at Villa Rica have a gold museum, and they claim that they were the first gold mine in Georgia, although the people up in Dahlonega will dispute that. But they claim that there was quiet gold mining going on as early as 1826 in Villa Rica. 1827, the Brewer gold mine was opened. The Hale gold mine shortly after that. The Hale gold mine, I think, is open today. I was on a geology field trip. They were preparing to open it, but there's still gold mining going on in South Carolina. And then the first discovery, widely acknowledged discovery of Georgia gold was at Duke's Creek, which is just outside of, basically near Helen in White County in 1828. But the gold rush didn't happen until the gold was discovered in Dahlonega. And suddenly 15,000 people came to try to make their fortunes in Georgia. So why wasn't there a gold rush before that discovery in Dahlonega? Well, it had to do with the boundaries of who had what land. And that land was Cherokee Nation land. And Thomas Jefferson had already promised the state of Georgia, when Georgia gave up what's now Alabama and Mississippi, that they were going to move those Indians out of there one of these days. And so it was more a matter of when, but basically because the Cherokee didn't have as secure a claim to the land in the eyes of the people of Georgia, this was just sort of, okay, we'll divide this up and you can go in and make your fortune on gold. So what happened was that before the Cherokee removal, you weren't allowed if you didn't have any Cherokee blood, you weren't allowed to own property in the Cherokee Nation. But after 1836, everybody had to sell it. But an example of somebody who had to sell their land was a very wealthy man named William Rogers, who just on the north side of the Chattahoochee in what's now, I guess, North Fulton County, had a $2,000 grist mill, $500 sawmill. You know how much money that was back in those days. That's a lot of money. Very wealthy man. Was forced to sell it, and he moved to Oklahoma, and he had a descendant with the same name, and who said, good judgment comes from experience, and a lot of that comes from bad judgment. So he was a funny man, Will Rogers. So get to the geology of all this. First you look at just what the physical provinces of Georgia are and of the southeast. And so the southern half is the coastal plain, which is pretty much just loose sediments very few hard rocks that settled out along the shores of the Gulf of Mexico, Atlantic Ocean, as their shorelines move back and forth across this area over about the last 100 million years or so. And then when you go to the northwest part of the state, you're talking about sedimentary rocks. Right here at Cartersville, we're on the boundary, essentially. And from here, northwest of the Valley and Ridge and the Appalachian Plateau, we're talking about sedimentary rocks. And they were beside an ancient ocean that's now gone. And how can an ocean go away? Well, it closed up. As you know, continents move around. And it closed up when Africa collided with North America. And then these rocks of the Piedmont and the Blue Ridge, which essentially are the same kinds of metamorphic and igneous rocks, just that the difference is really the Blue Ridge is the rugged part of that geologic area. Those were rocks that were scattered across that ancient ocean on both sides of it, really. And when it closed up, they got shoved deep underground, and they went through heat and pressure, and that changed them to metamorphic rocks. So everything's metamorphic in that area. Or some of the rocks actually got hot enough to melt and cooled off deep underground, and those are igneous rocks. So metamorphic and igneous in the Blue Ridge and Piedmont, and sedimentary up here, loose sediments in the coastal plain. So these are not only physical regions, these are geologic regions. And so the gold is where the metamorphic and igneous rocks are in the Blue Ridge and Piedmont. And so the cover of our book, these are basically, these different colors are age boundaries. So the oldest rocks in the coastal plain, and these are the youngest, and each one of these stripes is getting younger and younger age rocks. These are different age sedimentary rocks here, but we'd use a different color scheme for this because we have this terrain situation. So these color codes, so the purple color code represents this purple terrain called the Tougaloo or Tougaloo terrain. I hear different people pronounce it different ways. So these are what we call terrains with an NE. And so these were pieces that were scattered across that ancient ocean. And over some period of time, it all collided together. If you think about an analogy today, think about flying from Australia to China, and you would have New Guinea, you'd have Indonesia, you'd have the Philippines, you got Taiwan, off to your right's Japan. All these are little separate pieces. And if Australia should slam into China, then all of these things get jammed in the door, and some poor geologist has to figure them all out. And that's what we do with deal with terrains. And as I said earlier, the rocks got cooked, if you like, by the heat and pressure that happened during those collisions. So this is a 600 MA. MA is million years. This is planet Earth 600 million years ago. And I'm going to start a, let's see, I want to be, how do I, yeah, I made a pointer out of this, and then I decided I wanted the wooden pointer instead. So let's see, how do I get rid of the pointer so it'll actually work as a mouse? Thought it would be easy. What's happening here? Okay. Okay, well, no, it's still. Okay, well, I'm going to do it, start it up, and then maybe this will do it. Okay, I probably should be able to pause it with this, I hope. Nope. I may have to come all the way out of my presentation and go back in. Let's see. Okay, did I get it? Okay, now I can, actually, what I like to do with my mouse is drag us through this. So if I go back to the beginning here, yeah, let's see, do this over here. Go back to the beginning. Here's back to 600 million years. Okay, so now, so we're going to start to this, at the beginning, we've got a sort of a massive supercontinent around the South Pole. And you've heard of a supercontinent when all the continents were together, starts with a P. What's the name of that? Pangaea. This was the supercontinent before Pangaea. It's called Rodinia, which is from Russian for motherland. Pardon? And so you're just about to see. That's an important question. So what's going to happen is Rodinia starts to split up. And then let's pause it a second. Okay, so this is North America here, and there's Greenland tucked into it. This shows that's Hudson's Bay. This is the Great Lakes. Those didn't exist at the time, but they're good reference markers. And so this is the east coast of North America. but it's missing a little projection that should be coming out right there, which would be what? Florida. So it's missing Florida. So Georgia, the north half of Georgia is right about there. But the south half of Georgia is actually still on the other side of the ocean with Florida. And this is the tip of South America upside down. You'll start to recognize these pieces as they go. All right. And so this is actually Northern Europe. There's Scandinavia. And we see the chain of islands that came loose from Africa. And together with the Scandinavia piece, it comes in. This is kind of the first collision. Oops. Yeah. Back up. Yeah, let's drag it up to here. All right. You can see it again. All right. So this comes loose in a minute, a few million years from now. There we go. Okay, that comes loose, gathers together, and we get to our first collision. I should be able to stop it with clicking this. Yeah. Oh, did the same thing. Okay, I will go back, and this next time I'll do it a different way. Okay, that's why I like to drag this thing down to the bottom. There we go. Now I control it. All right, so we get to that point, about 400 million years ago. This is going to relate to our Dahlonega Gold Belt story. This is kind of the beginning of part of the Dahlonega Gold Belt story. It's about 400 million years ago. And then here we go with here's Florida, there's South America, Africa, and we come together, and now we've got Pangaea. And then as we watch this happen, continue this on here. Okay. Then Pangaea starts to split up. And you can start to recognize some of these pieces, like, what do you think this piece right here is? That's India. So here's Australia, there's Madagascar. And India's going to sort of skitter across there and run into Asia. And what happens when India runs into Asia? The Himalaya mountains get pushed up. And you notice that the Arabia and Africa are still joined together. So kind of one of the most recent events is starting to open a new little ocean there at the Red Sea. Okay. All right. So that's kind of an overview of the big picture. But the next thing I want to show you is how the gold fits into this. So this is where the gold maps show in Georgia, and I've got a few of the Carolina mines as well. And the strong concentration is in this yellow terrain, which is called the Dahlonega Gold Belt. In the book, we call it the terrain that was discovered by prospectors. So it's essentially a separate little terrain. And then more gold is down in the Carolina superterrain, including these active gold mines in Carolina. Now, so the Dahlonega Gold Belt comes right across familiar territory here. Here's Ackworth, Woodstock, Canton. It's coming right through there. And here are the gold mines that are mapped that existed along there. And one of them up in here is called the Sixes Gold Mine. And if you go to Tellus, they've got this lovely piece that came from the Sixes mine. So this was gold mining territory coming right through your neighborhood. And the best road cut in it is actually this very familiar cut to most of you, probably just as you're coming across Lake Allatoona and you're going down the hill, and here's this long road cut. And that's what the Dahlonega Gold Belt rocks look like. Okay, so I'm going to take us through a journey of the terrains. Now this green Carolina superterrain was actually over against Africa at the beginning, so it won't even appear in this first picture, which is 460 million years ago. But we'll watch these other terrains kind of move in. And so the first thing that happens is that this collision that the Dahlonega Gold Belt runs into the rest of North America, which I've got in tan here. And then we got another collision. Now notice that this is Atlanta's piece and all that is way up the coast here. So when this collision happened, it actually, we can see the effect over here because the sand and gravel and stuff that came out of it makes up the rock that makes up some of the ridges like Rocky Face Mountain as you're going up towards Dalton and all that. So there's plenty of sand that came off of this collision. But when Atlanta is going through its big thing, it's nothing but clay down here. So the suggestion is that probably this was happening up the coast because there's plenty of sand and gravel and stuff up of this age in West Virginia and Pennsylvania and so on. So that's when this collision happened up there. And then we got to shift it all down. And so just like in California, you've got this thing that's moving. What's the fault called in California? San Andreas. So this thing that's moving, Los Angeles will be north of San Francisco one day. And everybody will have to move because all Southern Californians, Northern Californians will feel very differently about the world. That's kind of shift is what happened here with a bunch of different faults moved this piece down. And so, yeah, just go back to this. And so we got everything kind of assembled here, except it's waiting to come in. This is still sitting out around where the coastal plain is. So there's 100 miles of transport that happened. And when Africa came in, it shoved it the rest of the way and got everything into place. Okay, so let's relate this to the gold story. So the Dahlonega gold was happening when these were volcanic islands, more than 460 million years ago and preceding. This was a chain of volcanic islands that was out there sitting about where Charleston is today. And so what happens? How do you get gold? Why does volcanic activity on the seafloor produce gold? Well, you've got water that's coming down, salt water, that's seeping down into rock, and it's somewhat corrosive. And as it gets down, it starts to pick up minerals, and it becomes more corrosive as it gets more acidic, reacting with some of those minerals. And then it starts to leach some of that stuff out of the rock, including gold and so on, and dissolves that from the rock. And then the gases from magma that are coming up to make this volcano on the seafloor are gonna bring more stuff into it, maybe dissolve more metal out of the rock and all that. And then the fluid comes back up to the surface, and when it hits the seawater, it reacts again, and you get something kind of peculiar looking, which is, you don't really appreciate what that's a picture of until I make it into an animation here. So let me see if I can get it to go. Well, I guess if I just hit one more key, it'll go, won't it? No. So I have to do this. Yeah, here we go. All right, so there's a mechanical arm. And so this is black stuff coming up out of one of these vents on the seafloor. It's called a black smoker. And it builds up these tall chimneys of metallic stuff on the seafloor. They talk about more and more about getting down there mining some of this stuff. So you get these chimneys on the seafloor. And this is also the place where deep ocean things have found these really strange organisms that live without photosynthesis. They're chemosynthetic microbes that are using the energy of these chemical compounds to create a whole life community. You got these tube worms and stuff. So this kind of a situation does more to perhaps produce the right chemistry to have a concentrated gold in rocks. Okay, so we have that's how the gold gets started, and we get this gold-rich terrain around these volcanic situations. And then we have other things happen that help to enrich it further. So when we get this event where these things move down in particular, the gold starts to move into veins and intrusions. So a vein is where you've got essentially hot water in some kind of super pressurized state that has mostly just silicon and oxygen, silicon dioxide, quartz dissolved in it. And you get these quartz veins from this hot water. And so there's a fair amount of, actually a lot of the gold is actually in pyrite, which most of you probably know pyrite is also known as fool's gold. So a lot of the actual real gold is some of it's inside the pyrite, fool's gold, associated with these veins and also associated with the intrusions. Some magma was coming out while this sliding was going on, Stone Mountain being a big example of some of that was contemporaneous with that sliding, but smaller intrusions. And these are both taken from Consolidated Gold Mine in Dahlonega. Anybody been to that? It's underneath the Walmart, but you can and at the surface you can pan for gold and gems and everything from all over the world, as I like to say, but they will take you down into the mine. And there's a really colorful guide that gives you a tour, and so you can see some of this stuff down there. All right, so the gold moves into the veins and intrusions, and then we get this final collision, and we produce Pangaea, and we get this mountain range, probably the scale of the Himalayas, but probably a lot longer than the present Himalayas, and then that wears down. As Pangaea splits up, that all moves to where this new ocean is in the coastal plain. And then after that, as the rock gets close to the surface, you get a lot of deep weathering because Georgia's we went through some warmer climates in the early part of the Cenozoic era, the present era, like 50 million years ago. And Georgia's always been kind of warm. So we get a lot of intense weathering. And it's left the rock has become rotten and the gold doesn't get weathered. And so when that gets washed into the streams, you get these placer deposits, which are where the gold, though the gold's much finer grain than all this gravel, it falls out with the gravel because it's so dense and heavy. It stays with the gravel rather than washing with the sand grains its own size down the. So Julian Gray, I don't know if anybody remembers Julian at Tellus. He's now running a museum out in Oregon, but at the time he was curator at Tellus, he made this series. And then I gave this talk or a similar talk in Dahlonega, and this woman gave me her little book. And these two are my resources for the history that I'm going to be sharing with you. So this is, the purple ones are Julian's slides. So placer gold, everything kind of gets mined in reverse because the placer is the most concentrated. So the stuff that formed last gets mined first. And that was even before the Cherokees. I saw this same illustration upstairs, by the way, in this museum. Then they started using the local water power and sluices and all that to separate the gold out. Then California's gold rush happened about we had 29 gold rush year, and of course in 1848, this nugget was discovered at the Sutter's Mill owned by James Marshall. Oh, no, James Marshall was the discoverer. I guess Sutter owned the area. So they found this gold. Now, according to Anne Dismukes Amerson, what happened then was that they found this nugget and nobody was really sure that it was gold, but she had been in the Georgia gold rush. And she said, well, I'm going to drop this in the vat of lye here, and if it's all rusty and cruddy after being overnight in my pot of lye, then it's just fool's gold and you can forget about it. But if it's still gold, then you got real gold. So she validated this discovery. So another person whose story figures in this is this man who was the assayist who they brought the gold in and he figured out how much it was worth and so on, and this for the mint. And when the California gold rush starts happening, this building, which was the courthouse of Dahlonega in 1836 and is now the Dahlonega Gold Museum, he stood up on this porch and made a famous speech. And he said, look, over there, Findlay Ridge, there's plenty of gold there. Don't leave here. We need you miners here in Georgia. There's millions in that Findlay Ridge. Of course, millions is an enormous sum. We say billions now, at least for what was millions back then. So there's millions in it. Got picked up by this man in these two books. A character named Colonel Mulberry Sellers. He said there's millions in it, and then that Hollywood probably changed that into there's gold and then our hills. So that's the story about that. So after the Civil War, they got very efficient with this and started using these fire hose-like nozzles. They'd route the water down from high up in the mountains and bring it out of these nozzles, and they did a lot of environmental damage. If you go to Smithgull Woods State Park, which is just outside of Helen, that's area that was damaged like this, but is grown back in beautiful forests because we get lots of rain here in the east. They took this same method out to California, and there are places out there that are still, totally destroyed environmentally because of this method, because they don't get as much rainfall as we do. So going on from that, so the mining from the bedrock, after they'd exhausted what was in the placers, and then they'd blasted that out to get the stuff out of the rotten rock, the saprolite, the weathered rock. Then they had to get into the hard rock. And they started using these stamp mills that could be heard from like 5 miles away. And John C. Calhoun was one of the investors. So this is the Calhoun mine. And there's still a mine open to tourists, at least a few years ago. I guess it's still open, the Crescent mine. And they crush ore, and so you can see what one of those stamps looks like. And this is Julian's acknowledgement to Bob Cook, who later he and Bob co-authored The Minerals of Georgia together, and some of these other folks. So thanks to Julian for providing this. So this is a map that I made that unfortunately they didn't put in the book. The book, things got left out of the book. But this is where Atlanta is. Here's 285 going around it. And here are the various railroads of different times and different dates. But this one to Montgomery was 1854. This one, Macon and Savannah, is 1846. This one from Augusta is 1845. But of course, you know about this railroad that runs through Cartersville. So this railroad thing happened after the gold rush kind of accelerated the removal of the Cherokee people out of northwest Georgia. So then they completed this rail link in 1845, 1846. Now, this is the Eastern Continental Divide coming through Atlanta. Follows this railroad exactly because the railroad followed the divide to minimize stream crossings. And it was just a question of picking where would they want to get a railroad going up here. And they considered doing it out here at Tucker. But they wound up saying, okay, we're going to build it right here. And that was what determined the location of Atlanta. And this is like a couple of blocks from the state capitol, is this point where the railroad separated. It's 5 points essentially today. So I went to a good talk by Ken Wheeler. Anybody know Ken Wheeler over at Reinhardt College? He's a historian over there. And he did a talk about intertwining gold, religion, and education in northern Georgia. And some of his points were that the gold rush advanced Georgia's technology. It brought in technological experts. So now I had an ancestor named Jacob Stroop, and he came to Habersham County, attracted by this. He was one of the people who started an iron forge to sell stuff to miners. And after he got through there, he came over here to Stamp Creek. And upstairs, you'll read about his two sons as getting credited for starting Stamp Creek's iron forges and stuff, which led to the Cooper Iron Forge, which you'll hear about next week, or next program that comes along. Cooper Furnace and all. They sold, the Stroops sold that to Mark Anthony Cooper. But anyway, so this is a technology angle. And the other angle that he was bringing up was Young Harris College, Emory University, were Methodist colleges, and a lot of the money for that came from people who got rich off of the gold rush, according to Ken. Now we're switching to the story about generals. And Steve Henderson has retired, but he was at Emory Oxford, and he did a for a 1999 Georgia Geological Society field trip. Part of the field trip was he was taking us around and telling us about how the Civil War and geology fit together in Northwest Georgia. So a lot of this comes from him, but any errors, of course, are my own. So, and this is one of the places we'll talk about. This is near Dug Gap in near Dalton. So, you know, geology makes the chessboard. If to the extent that war is a strategic game, geology determines a lot of what you're fighting on. So, so back to this map, we're going to zoom in on this area of the map, the Northwest Georgia area, and they're just the series of battles that started in 1863 and made their way across the valley and ridge. So these are the battles we're going to talk about. One of them, at least one of them, is not really a battle. It was just, but these were events, let's say. And so we'll be talking about all these. So the landscapes, the reason we have these ridges and valleys in the valley and ridge is a direct reflection of the geologic map. So you know this, what's in brown on this map, two different sets of map colors I've got, but that's another story. Anyway, you know, the ridges are a reflection of the particular rock types. Now, this is an illustration from the book that goes through Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvania. And these are the different geologic periods of the Paleozoic era, which is the same stack, more or less, that you see in the Grand Canyon. You see more or less the same period of time represented there from about 540 to 300 million years ago. And one of the things geologists like to do with a stack like this is to represent which are the more, as if you could see it all in one cliff, you'd have some ledges sticking out where you've got more resistant rocks. Of course, this is thousands of feet, but conceptually, this is like looking at a cliff with a bunch of ledges sticking out where the more resistant rocks are. And those more resistant layers are the ones, are what we call ridge formers, but they also form plateaus, mountains, hills. And so the two kind of ridge forming things, basically it's the mineral quartz. Quartz is such a tough mineral, it's not very susceptible to chemical weathering at all. And one form of quartz, of course, are grains of sand or little quartz pebbles. And the sand or the pebbles, sand makes sandstone, pebbles in sand make conglomerate. So that's one kind of resistant ledge. The other thing is something called chert, which is microcrystalline quartz. You might know it as flint. It's what Native Americans use a lot for tools and so on. And there are a lot of rocks that would be completely dissolved away and kind of are, except that the chert in them was resistant. And so, and those are what we call carbonate rocks, limestone and dolostone. That's calcium carbonate, calcium magnesium carbonate. And so we have several layers in the valley and ridge that are chert-bearing carbonate rocks. And those are our other resistant. Notice they don't stick out as far as ledges as the sandstone, so they're not quite as resistant. This Rome formation, by the way, well, if you go to Bartow, we're sitting on the edge of this, but the hill that the library and I guess the current courthouse sits on is a ridge of the Rome Formation sandstone. The valley on the other side is the Conasauga group. And when you get up to Quarry Mountain, you're in the Knox. So ridge valley, depending on which kind of rock layer is sticking out of the ground at that location, or not, or having been totally dissolved away. So the Chickamauga battlefield was on the limestones of the Chickamauga group, which obviously was named after Chickamauga Creek. They're both named after the same creek. And adjacent to it is this hilly area is in the Knox group. It's this chert-bearing limestone and dolostone. And so the Knox group was kind of acting like a sponge. Carbonate rocks dissolve with slightly acid rainwater, so the caves are in that. And caves also translate into groundwater. And so groundwater can translate into springs. And so the reason that there was a mad battle at Chickamauga was that this is where the Union troops assembled at Crawfish Spring, which is just outside the town of Chickamauga, just on the south edge of town. And there was somebody's rich person's house that he took over. But this was the water source that they assembled at. The water source is there because this sponge-like Knox group that's elevated is exuding its water here into the area. Okay, so meanwhile, while he was camped out there, General Thomas was coming in from over towards Nashville and was coming in with his troops and needed to get over Lookout Mountain, but they were coming through this place called Lookout Valley. And Lookout Valley is a good place to learn about how the structure, the way that rocks are folded and faulted affects all this. So here that shows in the back that Lookout Valley was originally a big hump in the geologic layers. But what happens is erosion cuts through the hump and down to the less resistant layers, and the less resistant layers make it a valley. So the layers were arched upwards by the earth movements, this same collision, the Africa and North America, and then the arched layers later erode to make a valley. And so, so I've played with this some more with using Google Earth, because you can get some of this relief. You can sort of, see here's the plateau of Lookout Mountain and all that. And then I can overlay geology on it. This is Chattanooga's right out in here. This is Lookout Mountain, Cloudland Canyon. This is called Sand Mountain over here. That's Lookout Mountain. This is Lookout Valley. And so if I overlay on it, this is where the sandstone and conglomerate is that makes those plateaus, that makes them high. And this is the valley has this more easily eroded limestone, shale, and siltstone. Now, this line across here is going to represent where I'm going to pull a slice up out of the earth. So I pull up that slice a little ways, and now you're looking at, here's the top of Lookout Mountain, and then here's the valley, and here's what's going on underneath in the rock layers. So here's this hump that I'm talking about. And this is a fault. The red lines are faults. If I pull this further out of the ground, you see what's driving this hump is what's happening is that all these layers are getting shifted from the right, and they're getting pushed up this little fault, and they curl over as they push up, and that makes the hump. That makes the anticline, we call it. And the anticline is what gets eroded into. So that's why we have these linear valleys, is because we have these sheets of rock that have kind of slid up over each other like shingles on a roof. And where you've got a little hump like that, it can turn into a valley. So zooming out, we were just looking at this little area right here, and this is the cross section all the way across the valley and ridge. And what you're looking at of the geologic map that looks like bacon or something, all these little layers, it's kind of like if you took a jelly roll and sliced across it, you'll get a bunch of stripes, right? So this is why you get all these stripes, is because all these layers are being planed off at the surface and giving you this kind of striped map pattern. So the whole width is folded and faulted during that collision, and then the erosion produces the striped map pattern. And then the difference in how easily they erode, as we say, makes the plateaus, ridges, and valleys. Now, there's one other feature here, which are these zigzags, and this takes us another more of a complication in terms of structural geology. That's my particular area of geology. That's what I went to work for the oil companies for, is look at structures that might have trapped oil, kind of thing. So looking at these structures, why do we get zigzags like this? Well, it has to do with plunging fold hinges. So if you take something that it has like this, and you hold it horizontally and you plane it off, you're going to get straight lines. But if you hold it at a tilt and you plane it off, you're going to get these zigzags, right? And so it's like you tilt it. Here's my sheet of paper that I just tilted, and here it is crossing a horizontal surface. So you get this kind of a pattern. And here it is here. You've got these layers folded in a concave up fashion, and they're tilted like this, and you get this, the plunging syncline means that it gets wider here, and the plunging anticline means it gets narrower there. So back to the Civil War story, one of the events that happened to General Thomas, he got his troops over Lookout Mountain. They're coming down, I think they came down the current road into Macklemore Cove. From there comes right down this little thing here. And Bragg was over here in Lafayette, Georgia, and he had some scouts sitting up here. Now, if you go right to that spot, you'll see this sign that says, "Skirmish at Macklemore's Cove, opportunity lost." And what happened was they had some miscommunication, but what Bragg wanted to do was to trap Thomas in the nose of this plunging fold, essentially. They had some miscommunication, and he failed to do that. And so Thomas was able to successfully join the others here at Chickamauga, and then they had the big battle at Chickamauga. And this is, if you go to the battlefield, there are monuments to soldiers of all states. It was one of the bloodiest battles in the Civil War. It was also the last one that the Confederates were really successful at, a last large battle that they were successful. And what they succeeded in doing was confining the Union troops into Chattanooga, where they put them under siege. And what confined them was, again, the geology. On one side is Lookout Mountain, which is held up by this sandstone and conglomerate we were talking about a minute ago. On the other side is Missionary Ridge, and it's one of these lower ridges, but it's one of these chert and dirt things. All the carbonate rocks that had the chert has dissolved out, but it's a lot of chert in there, and so it makes a hilly kind of a ridge. And so they're sitting in here, and of course they had one battle with Lookout Mountain. One of the things that happened in the Battle of Lookout Mountain was that the Confederate forces had cannon up there, but the cannons wouldn't tilt down enough to shoot the troops that were climbing up the mountain. So the mountain was not so cliffy that they couldn't climb up it, but it was too steep for the cannons to be able to turn down and shoot at them. So that was Battle of Lookout Mountain. And Missionary Ridge followed. And then the Union broke out then in these two battles, and that started the Atlanta campaign. And they went to Ringgold Gap first. And Ringgold Gap, again, just pointing out the thing about this landscape, this chessboard essentially that's made. Again, in this color scheme here, the sandstone that I showed you in tan earlier is in purple in this color scheme. And so that's the sandstone. And then the reddish is that cherty rock, the chert-bearing rock. And so getting towards Ringgold, you come over this hill on the chert gold rock, and you're looking into Ringgold, and you see this, and this is the sandstone ridge. This is the part of the railway depot in Ringgold. And one of the things we talk about in the book is this is this native sandstone. After the Civil War, they filled in with this limestone, which has its own story. But why do you suppose they had to fill this in? Why did you have to repair the train depot?
Cannon damage?
Yeah, cannon damage. So the cannons, so you can go look at that railroad depot in Ringgold, and you've got the sandstone building with this later repair of limestone that shows you where the cannons damaged the railroad depot. And this is one of the maps that we use in the book. So it points out all the places, including Ringgold Gap. And so this is the ridge of Taylor Ridge that's there behind Ringgold. And this general was rolling stones down off the ridge onto the Federal troops. And by that method, this is the field hospital. That's the railroad station with you can see the places where they had to patch it with a little bit. This is another building, contemporary, built out of the same stone that got turned into a field hospital. But basically, he managed to give the slow-moving supply trains of the Confederacy time to get out of the area by rolling stones down on the Federal troops. And so that put everything on pause from November until May of the next year. And all the federal troops were camped out on this side of Taylor Ridge in Ringgold. And the federal troops, the Confederate troops were over in Dalton area on this side of Rocky Face. And so in between is Tunnel Hill, and Tunnel Hill is there's a tunnel, historic tunnel. In fact, you can see this is still the 1836 tunnel or whatever the date, that's the early tunnel, was a great engineering feat of its time. And you can walk into that tunnel, there's a little museum there, and this is the tunnel that's currently used by the railroad. But the reason it's there, the tunnel had to be there, is because all the water on this side drains into the Tennessee, and the water over here drains down to Mobile Bay, and so it's a drainage divide. Well, in May, when Sherman got ready to move, he managed to grab this before the Confederates had a chance to blow it up. So this tunnel is still there because of their mistake, and that really made it easier for the federal troops. Then they started. They were pushing on three fronts against the forces in Dalton. Mill Creek Gap here, down here, and at Dug Gap, which is literally dug out of the ridge. And at Dug Gap, the Confederate troops were using rocks again to roll down on the Confederate forces. On the Union forces. So the Union force didn't get a lot of success getting through Dug Gap. They had pretty good success. They got through here eventually, but down here was McPherson was trying to get down through Snake Creek Gap. All these little zigzag ridges have to do with these same plunging folds that I'm talking about. But McPherson gets through Snake Creek Gap and then looks up at, that's sort of foggy and all that, and he looks and he thinks that the Johnston has many more forces than he does. And so he holds off, and by that time, all the Confederate forces that are up here at Dalton manage to come down and rejoin them. And then they have a big battle at Resaca. And that's another one, that's the other really bloody Georgia battle, I guess, that happened in Resaca. Okay, but then after Resaca, after the federal troops won in Resaca, the Confederate troops didn't have any place to fall back on until you got down past Cartersville. And the reason for that is, again, geology. If you look at these layers, when you get out in this area, you notice back here you got all these steeply tilted layers, and when you plane off a steeply tilted layer, you're going to get a nice narrow ridge. But these layers are nearly flat, and you plane those off and you get sort of broad humps. And so these broad humpy areas are the Knox group, the resistant cherty stuff, and it's just not a good defensible position. So the Confederates had to retreat south of Cartersville. And so as usual, I'm coming up on 1 o'clock, and I'm barely going to get to the Tightrope Walkers, but I hope to get there. So anyway, we moved the battles into the Blue Ridge and Piedmont. And so now this is a big fault. You remember I showed you that the Blue Ridge and Piedmont moved 100 miles to the northwest, and this is the fault on which they did it. And so these rocks are, you can actually tell that the sedimentary rocks extend back that 100 miles when you use the seismic imaging like you use in the oil business to look into the ground. So all those rocks are metamorphic and igneous. It's more rugged because those rocks are tougher than the rocks of the valley and ridge. And when you look at this as the Atlanta area geologic map from the book, all the purple color scheme because we're in that purple terrain. These are granite bodies, Stone Mountain and all that. The rest of it's metamorphic rocks. But this complex geology means that you don't get those long continuous ridges and valleys. You get a few ridges, and one of them is Kennesaw Mountain, where you've got a granitic gneiss, a pretty tough rock surrounded by a much less tough rock that's basically metamorphosed basalt called amphibolite. And so And if you climb up Pigeon Hill, you come up out of this red dirt where the weathered amphibolite was and up onto this light-colored rock of the granitic gneiss if you're going up over Pigeon Hill. And so, so that was a battle there. There was a ridge to defend there. After the last battle was an attempt to come back. The Confederate troops tried to cut the supply lines for the Union. This was and still is, a cut that was made for the railroad back then. Now it's a bike path, walk and bike path. Really neat little place. And this was where they tried to cut the supply line. So that's the last of those battles. Tightrope walkers. Okay, I've got, I'm coming up on 1 o'clock here, but there were there were two tightrope walks. One, nobody really knows who this guy was, but this was his stage name, Professor Bachmann in the 19th century. The Carl Walenda, this is him in 1970, with all these people up here watching. And then his great-grandson was going to walk in 2015, but didn't get offered enough money or something. And so that didn't happen. So why Tallulah Gorge? Well, these are profiles across other eastern gorges, and you notice they're all pretty gently sloped, and Tallulah Gorge has a steeper slope. And it's the fourth deepest canyon, you know, all this information. Why so steep? So here are those other three. Here's what Black Canyon of the Gunnison, which inspired like the Roadrunner cartoons and stuff, in out west looks like. And there you've got, you know, rapid current uplift, more or less, that's allowing you to get these steep wall gorge. And so how do you get a steep wall gorge in Georgia? How do you get current, you know, a young, relatively young, 10 million years or less, let's say, feature in Georgia? So the origin was speculated about in 1907, and here's the area we want to watch. So this is the current map, Tallulah and Chattooga going down the Atlantic. This goes down to the Gulf. But millions of years ago, abracadabra, okay, you had the Chattooga River, and the Tallulah ran to the Gulf, and the Tougaloo River ran to the Atlantic. But this area had headward erosion, kept eroding up at the headwaters of the stream until finally it captured that. And today, like this, you know, this is still up at 1140 feet above sea level. This is down at 675. So this is why the Chattooga is such a wild and crazy, wild and scenic river. Has all the rapids in it, and they filmed Deliverance there and all that, because it's coming down to this elevation. And the Tallulah, because it's cutting across a tough rock called quartzite, it even made a more spectacular kind of thing. And even, you know, you're getting erosion, of course, is still continuing at these waterfalls. So that's Tallulah Gorge. Now, if you want to learn more about it, go to this guy's YouTube page. I think I've got the QR code that's going to come up in a second. Philip Prince, but it's called the Geomodels. And he tells about, one of the lines of evidence that was used by Johnson was there were differences in fish species on either side. And now with the kind of genetic clocks, you can sort of know that it was maybe about 7 million years ago or so that these different bass species diverged from each other, which was caused by the fact that the drainage system changed. So he explains it beautifully. And he was the guy who, you'll see noted in my book, he gave me all the advice on landform evolution and stuff. But now he's a YouTube star. He has thousands and hundreds of thousands of views for a whole lot of different videos. And so check out Philip Prince's The Geomodels. Okay, so I always like to finish up. I've credited a lot of people, but this woman was the person who invited me into her book project, and I got to work with her, and she still teaches at Georgia Perimeter, Georgia State. And this is the, if you came in late, I've got books available for 24 plus tax, or if you've got cash, I'll just take 25, but I can use credit card. I've also got t-shirts like this. And if you want to see more about walks and talks, we got that. So just past 1 o'clock. Time for questions?
Do we have any questions?